All right, we're in AP Calculus, lesson 3-1, height, slope, and concavity. Welcome to your new unit. Everyone sees your unit guide. We have 8 lessons, 4 self-checks, and then our pre-test, fix-up, and test like we normally have. Yeah, today's date is Tuesday, October 13th, 2020. Our objective today is to, Chris.
Identify what height, slope, and
concavity. It's like a cavity that you have in your tooth, but concavity.
concavity means good function, rotation, and graph. So F,
Double prime. Yeah, and then you can have F triple prime, F, and then it's just, it kind of gets tedious after that point. So let's start with some vocab. So if I have a graph, if I have, I don't know, some point on the graph, I'm just going to make it right there. It has a height. So I'll say that its height corresponds to the y-axis. So we'll label that. That's our height. I should make my height a little bit bigger. That's our height. The slope, of course, you guys know this really well. The slope of the line tangent. If I were to draw the slope, it would touch this point once, but it wouldn't go through anything like that. It touches it as if it's the same slope at that instantaneous point. So let me do my best attempt of drawing a slope here. Actually, I have a line tool. I should use that. I'll go ahead and draw a line that's about that slope and then move it. So that red line that I've drawn represents slope. And then you have concavity, and that's kind of the new word of the day. So concavity is, how are you curving? Are you curving up or are you curving down? So I'll use orange typically for that, but I can say this curve over here on the left, this is all kind of facing up. It's concave up. So all this is going up, it's going up. So I can say over here, this is concave up, concave up. And then vice versa over here, it's concave down, it's pointing down. This is all concave down. So when I'm talking about concavity, I'm literally asking, is it up, down, or is it not either of those? Because eventually there is a point at which the concavity has to switch. And if I had to guesstimate, it looks like it's at the origin, right? It looks like right here at the origin, I am neither concave up nor concave down. So it does have a switching point. So height. In terms of F prime, F double prime, it's just F, right? If you see F of X, F of C, it's really saying the height of X, the height of C. So height is just F. And typically you want to think of this as the Y coordinate, right? So it's the Y coordinate. So if I look at the y-axis, that is the height, and it matches the graph for our definition. Slope, of course, is not F. It is now what? There it is. Fiona said it, F prime. And you want to think of that as the derivative, right? So this is the derivative. Sometimes we think of this as the tangent line. So if you see the word tangent, that's another word that goes along with F prime. And then finally, concavity, and as you guys can probably guess, that's going to be what, Andrea? F double prime. F double prime. And you're either going to have 2 types of concavity, right? So you're going to either have concave up, and then you can do a little smiley face. And then if it's going to be concave down, it's going to be a rainbow. Or a sad face. I don't know. What do you guys want? I like rainbow because everything's then positive. It's nice and happy and cute, right? Yeah. We need more happy and cute things with 2020. Okay, so depending on what graph I'm giving you, though, these things might look different. This is all kind of assuming that I'm on a graph of F, but as you can see down here, I'm eventually going to be giving you a graph of F prime, a graph of F double prime. This means that everything in this orange line represents the second derivative. It represents concavity. What do I mean by that? Let's go ahead and talk about this. So if I have a graph of F, and that's going to be typically the case in most questions, if I give you a graph of F, height is height. Height is F. So height and slope and concavity, these are words that describe what's happening with the graph. It does not describe perfectly what's happening with the function, with function notation. Slope, you guys can probably tell me, you can all shout out, it's not F, but F prime, and then concavity F is what? There it is, F double prime. But what do I mean exactly? So let's look at the heights of each of these points. Let's look at the F. So if I say, what is F of A? So let's try that, F of A. And you're gonna write small because I need to fit in 4 of these things in here. So F of A, what is F of A? Is it 0? Is it greater than 0? Is it less than 0? It's 0, yeah. What about F of B? Teflon, what's F of B? Is it 0, greater than 0, less than 0? Less than 0, so I'll do less than 0. What about F of C, Fiona? Greater than 0, yep. And then what about Andrea, F of D? Greater than 0, yeah. So you guys can all kind of see how that matches up with the graph. We know what is happening in terms of F. Why are we doing this? Because eventually I'm going to be giving you a point like B, and I'm going to ask you, what's F of B? What's F prime of B? What's F double prime of B? And you should be able to tell me, oh, F of B is less than 0. F prime of B is 0. F double prime of B is greater than 0. Just by looking at that one graph. But I'm doing the baby steps so far. So slope, F prime. So let's do the same things again. F prime of A. That's a slope at A. F prime of A is at 0, greater than 0, less than 0. Go in circle again. So Chris, the slope at A, is it positive, negative, 0? At A over here, if I drew the slope, yep, negative. So I'll say less than 0. Fiona, F prime of B is equal to 0, exactly. And that's pretty cool, right? That means I have a horizontal tangent line. F prime of C, Andrea, is greater than 0. That slope is definitely positive. And Teflon, F prime of D. Not quite. So if you think of the slope over here at D, the slope is going down, so it should be less than 0. And then finally, we have concavity. So going around the room again, F double prime of A, Chris. Are you concave up or are you concave down? Or neither? Up. So it's going to be greater than 0 or less than 0? Yep, greater than 0. Like it's a positive amount. Positive means concave up. So maybe I should say up means greater than 0, down means less than 0. And then F double prime of B, Fiona. It is also greater than 0. It's concave up. And I can annotate this as well. That's concave up. That's concave up. What about F double prime of C? Andrea? Of C is less than 0. I agree, because if you come over here and look at the graph, this is concave down. And Teflon, F double prime of D. It is also less than 0. Yeah, F double prime of D is also less than 0. And again, I can draw this as a concave down. And I should come back in here and change the colors here. So just this line right here, I'm going to make that red. I try to make red just for the slopes. Concave, or so slope was negative over here, slope was positive, slope was negative, and the heights are very clearly, you just match it up with the y-axis. Okay, now we're going to try it again, but on a slightly different graph. I consider that one to be like the easy problem. These ones get more and more difficult now. So this is already a graph of f prime. So on a graph of f prime, what is height? If I say the height here for C, the height corresponds to this y coordinate. The height is now f prime because it's a graph of f prime. The output, the y coordinate, is whatever it's talking about here. Our shortcut is whatever it says a graph of, that is height. Up here, I had a graph of f, that means height is f. Down here, I have a graph of f prime, so the height is f prime. And I don't want to give too much away, but you can probably guess what height is going to be down here on a graph of f double prime. So let's start with just height. That's f prime. If that's height, what is slope? F double prime. F double prime. And then what is concavity? F triple prime. Okay, so F triple prime has a unique name. If you're thinking about it in terms of driving your car, F prime is kind of like your velocity, right? If your F prime is positive, that means you're going forwards. If F prime is negative, you're going backwards. F double prime is how fast you're accelerating. So are you like stopping at a stop sign? Are you hitting the brake? That means your F double prime is negative. Are you pressing down on the accelerator? That means your F double prime is positive, right? So then what is F triple prime? F triple prime in physics is called a jerk. And it means how quickly you step on the accelerator. Am I stepping on the accelerator nice and slow? Am I basically just holding the accelerator down as jerk 0? If I like really stomp on the accelerator quite a bit, then the jerk is positive, right? So we don't care about jerks in AP Calculus. And it's kind of a cool slogan, right? We don't care about jerks in AP Calculus. So right in here, we don't care about jerks. Not only do we not care about jerks, but we don't care about anything beyond F triple prime. We don't care about F triple prime, F quadruple prime. We only care up to the second derivative in AP Calculus. So we only have to do height and slope. So let's talk about F prime of A. F prime of A. That is going to be just the y coordinate essentially, right? So if I come over here and find the y coordinate, this y coordinate is at y coordinate greater than 0, less than 0, equal to 0, Chris? It's less than 0. So F prime of A is less than 0, which is kind of weird to think about. That means that the slope is less than 0, even though I'm talking about the y coordinate. It's because I'm talking about a graph of F prime. It's kind of hard to wrap your head around this, but F prime of A is less than 0. If I just ignore this graph now and only look at F prime of A is less than 0, that means the slope is less than 0, even though I was really talking about the slope on a normal graph of F, even though I was talking about a y coordinate, which is kind of mind-boggling, right? Fiona, what's F prime of B? Is greater than 0, yep. And F prime of C, Andrea, is less than 0. There it is. And then slope on a graph of F prime, that means I'm taking the derivative. When I take the derivative of F prime, you just add on another prime and I get F double prime. So F double prime of A, I'm really looking at the slope on this graph, and that represents F double prime. Teflon, what is F double prime of A? Greater than 0, perfect. Chris, what is F double prime of B? So you want to think of this as a slope, right? So back here, this was the slope was positive. Now the slope up here is equal to 0. Yeah, exactly. F double prime is equal to 0. And finally, F double prime of C, Fiona? It's less than 0. It is, yeah. That slope over here is less than 0. And again, we don't care about jerks. That's a graph of F prime. Let's try a graph of F double prime. All right, what are heights going to be on a graph of F double prime, Andrea? F double prime. Heights always match whatever the graph's name is. So F double prime. So I'll ask the same questions that I asked before. Let's actually get through all these first. Slope, therefore, Teflon is going to be F triple prime, which is called jerk, which we don't care about. And Chris, concavity is going to be, yeah, fourth derivative, F quadruple prime. And by the way, once you get into these higher derivatives, it kind of is tedious to write, like if I'm taking the 19th derivative, you don't want to write 19 of those. I call them tick marks, but I don't know exactly what the name is. There's a quick way of writing this one. This one can be written as F and then 4, but with parentheses around it. That typically means you're taking the derivative 4 times. It's not, you don't need it for AP Calculus. More of like, oh, when you go to Calculus, that's another notation you might see. You won't ever see that in the AP Calculus test though. And again, we don't care about anything down here. So I'll say, don't care. I only care about F double prime. That's the last thing I care about. So I'm going to ask you questions about F double prime of A, B, and C. What's F double prime of A? And that's going to be height. So we'll start with Fiona. It's greater than 0, because if I'm thinking of F double prime, that's really height, and height on this graph is on the y axis, right? The y coordinate is, again, greater than 0. Andre, what's F double prime of B?
0.
It is indeed 0. And Teflon, F double prime of C? It's less than 0.
So when it's 3 or more, you don't what is it?
Exactly, yeah. 3 or more, we don't care anything. And that's it, yeah. Give me a fist of 5 on our objective. How well can you identify height, slope, and concavity on a graph of F, F prime, F double prime?
Times
5, 5, 5, and 5. Wow, those are really high scores. That's awesome. Thank you.